Okay, guys, Mr. Pascas here. Today, I am honored to do graphing systems of equations. This is gonna be fun. I hope you wore 2 pairs of socks because the first pair is gonna get blown off with how much fun we're about to have right now. So let's just jump right into it. First things first, we are going to graph both of these equations on the same graph, and then we're going to interpret the data and see what happens. So let's just do it. Let's jump right into it. I'm gonna graph the first line. I got -8 on the y. 1, 2, 3, 4, 5, 6, 7, 8. I have a slope of 2 or 2 over 1. So I'm going to go up 2, right 1, 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 up 2, right 1. And I'm going to connect these with a green line, okay? Now, my next one, I'm going to do +7, -1/2. So let's just see what happens. 1, 2, 3, 4, 5, 6, 7. That's my first dot, sorry guys, there's 7. And then I'm going to go down 1, right 2. Down 1, right 2. So down 1, right 2. 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 I can even go up 1, left 2 if I wanted to, just a couple times because I'm a savage like that. There we go. Put as many dots as I can. And I'm going to connect these with a red line. Okay, so red, green. So what I did is I graphed both lines onto this graph using my y-intercept b and then my slope m, right? When I graphed this green line and red line, you can clearly tell they touch right here. Right there, when I'm drawing this arrow, right there, they intersect, they touch, right? They overlap, crash into each other. I don't know what words you guys want to use, but they touch right there. This is your solution. So wherever these two lines touch, that is your answer. So at this point, okay, so on the x value, that's right here, 1, 2, 3, 4, 5, 6. So that is 0.6, comma, 1, 2, 3, 4. So at 0.64, right, x value, y value, at 6,4, this is the answer to the system of equations. You graph each equation, wherever they touch, that is the answer. That is the answer to the system of equations. If you plug this answer into both of these, you'll get true solutions for both of them. That's simple. It's that easy, okay? Let's jump into another one. All right, same thing. I'm gonna graph both ones. I'll use green for the top. I'll use red for the bottom. I start at -2 on the y, 1, 2. I'm going to go up 3, right 4. 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. I can even do it backwards a couple times. 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. And we said that was gonna be a green line. That is a horrible line. Holy cow. Okay. Next one, I'm gonna go to 6, right? Because I'm starting here, my y-intercept. 1, 2, 3, 4, 5, 6. Put a dot there. And it looks like a similar slope here. Yeah, exactly the same. I'm gonna go up 3, right 4 again. 1, 2, 3, 1, 2, 3, 4. I go off the chart, so I'll go backwards a couple. 1, 2, 3 down. 1, 2, 3, 4 left. 1, 2, 3, 1, 2, 3, 4. And we said we're gonna connect this one with the red line. Now, from the first problem, I graphed both equations down here, right? From the first problem we did, I told you the answer is where they touched. There's a problem here. I don't see any touching between the red and the green lines. There's no intersection. It doesn't look like they're gonna touch anytime soon. And it makes sense because they have the same slope, so they're gonna be parallel to each other forever in both directions. So if they're never gonna touch, guess what? They are going to have no solution. There is no set of points that you can plug in the same to both of these equations and get the same answer or get true solutions. It's just not gonna happen, right? So there's no answer, no solution for problems that have parallel lines. Let's do our final one. I'm gonna graph this one again in green, the bottom one in red. I'm gonna just, State the obvious. It looks like the same equation, so let's see what happens. I'm going to go here at -7. 1, 2, 3, 4, 5, 6, 7. My slope, there's a 1 there, right? So it means 1 or 1 over 1. I'm going to go up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1. I'm going to do that as many times as I can. Come awesome like that. I'll even do a couple backwards. I'm going to connect those with a green line. Now, follow me here. I just graphed this one. If I want to graph this line, the red one, it's going to do the exact same thing. I'm going to start here. I'm going to have a slope of 1 over 1. So my red line is going to literally fall right on top of the green line because they're like the same line, right? So my green line and my red line are actually overlapped. They're the same line. I just kind of traced over it. So if my answers, wherever the lines touch, right? These touched once, over here touched none. These, it seems like it's always touching, right? The green and the red are always touching. So for a problem like this, it's gonna be IMS. There's infinitely many solutions. Every single point on this line is a solution. Any point that you choose from this line, these lines, and plug them into your system, you'll get true solutions, okay? It will work. And so that's it, guys. So when you guys graph these equations, if they touch once, you have an answer. If they never touch, you have no answer. And if they overlap onto each other, you have IMS. That's it. You guys have a great, wonderful day. Stay healthy, stay safe. Hope you had as much fun as I had.